Hello everyone. Welcome back to our CSAT course of permutation and combination lecture number 45. Okay. Now look at these questions. We'll see some of the more questions of permutation and combinations. So let us begin. Now look at this question. How many different triangles are there in the figure shown above? Okay. So usually what we do, we have n distinct points. Okay. We have n distinct points. So we can form how many triangles? NC3 triangles. Okay. NC3 triangles, because we choose any 3 points, we make a triangle. But see in here, if we see, we have these 2 points as collinear, we have these 4 points as collinear, we have these 4 points have collinear, these 2 points are also 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 collinear, and if we see, these all points are also collinear. So here we will not be able to apply our formula of NC3. Okay, so if you like, if you count the number of points here, so how many points are there? 1 2 3 4 5 6 7 8. We have total 8 points. Okay, and then we have three more points. Okay, we have three more points, so we have total 11 points. If we do 11 C3, we will not get our answer, because this will be a very big answer for us. 3 into 2 into 1. Okay, so this becomes 3, this becomes 5, and this is 15 into 11, which is 15 and 15, so this becomes 165. So this is not the answer for us, because these are points are all collinear. For n distinct point, we can use the formula NC3. Okay, I hope you understand this. For n distinct point, we can use this formula. Okay, so now what we are doing basically here is, let's start counting. So we have this 1 2 3 4, 1 2 3 4, and 1 2 3 4. So these are basically small triangles. Okay, these are basically small triangles. How many of them? We have 12 of a small triangles. Okay, 1 2 3 4, 1 2 3 4, 1 2 3 4, 1 2 3 4. Now let us start counting the bigger triangles. Okay, so we have one triangle, this one, and we have one triangle, this one. So two triangles. Similarly, we have one triangle, this one, and one triangle, this one. So two triangle, we have one triangle, this one, and one triangle, this one. We have two more triangles. So we have total six more triangle here. So 18 triangle. Okay, now let us count more, some of the more triangle. We have some triangle, this one, and we have this triangle, we have this triangle as well as this triangle, we have this triangle as well as this triangle. So how many triangles more we are getting? Six more triangles. So 24 is our total. Okay, now do we have any more triangle? Okay, do we have any more triangle? Let's check for them. Okay, now you will see that we don't find any more triangles here. Okay, you will see that we don't find any more triangles here. So basically our answer will come to be how much? 24. Okay, so basically our answer comes to be 24. So this is how we can do this question. Now look at this. A teacher has to choose maximum different groups of three students from a total of six students. Of these groups, in how many groups there will be included a particular student? So try to visualize what the question is saying here. A teacher has to choose maximum different groups of three students. Okay, from a total of six students. So you have six students. Let us consider them as A, B, C, D, E, F. All students are different, and we have to find three groups. We have to choose three groups of the students. Of these groups, in how many groups there will be included a particular student? So let us say we have already included A. Okay, we have already included A. So how many positions are left? Okay, how many positions are left for the other students to be filled? Two positions. Now how many children are left? Only five students. So in how many ways we can choose two students? 5C2. So our answer will be what? 5C2. And everybody knows that 5C2 is nothing but 10. Okay. 5C2 is nothing but 10. So your answer comes to be 10. Okay. Your answer comes to be 10 here. So what actually the question is saying, a teacher has to choose maximum group of different students of three students from a total of six students. So what the question is saying, that we have six students, we have to form groups of three students, and we have to form maximum groups of three students. Now the question is not asking how many groups of different students you can form. Obviously you can form 6C3, which is 6 into 5 into 4 divided by 3 into 2 into 1. So this becomes how much? 20. It is asking you that of these groups, in how many groups there will be a particular students included. Okay, so what here it is asking, that you have this A, B, C, D, E, F, Okay, so these are six students. So we have included this particular student A. Okay, we have included this particular student A. So how many students are now left? One, two, three, four. Okay, so if we are including this particular student A, then from how many students left we can choose? We can choose from the five students left. So, and how many we can choose? Only two students. So this can be done in 5C2 ways. Okay, so you can do this in 5C2 ways. So this will come to be 5 into 4 divided by 2 into 1. So this becomes 10. Okay, this becomes 10. So I hope you are clear with this thing. Okay. Now look at this. Three dice, each having six faces, with each face from one number to one number from 1 to 6 are rolled. What is the number of possible outcomes such that at least one die shows the number 2? Okay, so what this is saying you that three dice, okay, three dice each having six faces. Okay, three dice. So each dice has how many faces? Six faces. Okay, with each face having a number from 1 to 6 are rolled, what is the number of possible outcomes such that at least one die shows the number 2? Okay, at least one die shows the number 2. Okay, and what is the number of possible outcomes? Okay, so let us say we have three dice, one, two, three dice. Okay, now it is asking at least one dice should show two. That possibility we have to calculate. But see, at least one means it can be more than one also. It can be all three also. Okay, so we have to calculate each of these. Okay, so let us say this one dice is having number 2. Okay, this one dice is having number 2, and both of these are not having number 2. Okay, both of these dice are not having number 2. So how, so uh, this can show six kind of faces. Okay, okay, or we can take this can show five kind of faces because two is not coming here. Okay, because two is not coming here, and this can show five kind of faces because two is not coming here. We are calculating at least one is having two. Okay, at least one is having two, so that possibility we are calculating. So exactly one is getting, so when you are asked at least one is getting the number 2, so that means you have to calculate the possibility that one is exactly they should get 2, then two of them get 2. Okay, and all three of them get 2. Okay, all three of them get 2. Okay, so these are the possibilities we need to calculate. So first possibility we are calculating that at least one is getting 2. Okay, so exactly one is getting 2. So in this one we are saying that this one is getting 2 and both of these are not getting 2. So you have 25 cases like this. But then let us say this dies. Okay, so this one is getting 2 and both of these are not getting 2. So you have again 25. Okay. And then you have this dice is getting 2 and both of these are not getting 2. Then you have again 25. Okay. Again 25. Now let us calculate another condition that both two of them are getting 2. So we have 2 here and we have 2 here. So this can be done in one and one ways. And the rest assured we have 5 here. Okay, and you can have 2 here and 2 here, and you can have any of the 5 outcomes here. And what else is left? You can have 2 here and 2 here, and you have 5 outcomes left. So total how much outcomes are left? 75 plus 15. Okay, 75 plus 15. So that becomes how much? 90, obviously. Now see, we have one condition in which all three are getting 2. So that is one only. So the total number of outcomes you are getting is 91. So you get 91 here. Okay, so I hope everybody is clear with this thing. See, understand this question very well. What is happening here, that whenever you ask that at least one outcome should be there. Okay, so you have to calculate that at least one should occur. Okay, then exactly one should occur, more than one should occur, and the total number of cases also you have to calculate. Okay, so for example in this case they have given that there are three dices A, B and C. We are having three dices and these are being rolled. Okay, these are being rolled. So and this is asking to us what is the number of possible outcome such that at least one dice shows number 2. Okay, so if one dice shows number 2, so if this one is showing number 2, then this can be done in how many ways? Okay, this can be done in how many ways? this can be done in only one way because 2 is only one single outcome, and these are not showing any 2. So these can be done in 5 and 5 ways. Okay. And when this one is showing 2, so that one is only one outcome, and this one can show 5. And when this one is having 6, then only one outcome is possible here, and this one is showing 5. Okay, so basically you will multiply all these possibilities because these are mutually exclusive. We don't have to consider these are not tied or some restriction is there. So 25 these cases, 25 these cases, and 25 these cases. Total number of cases, how much you are getting? 75. Okay. Now the next is what? The next is you have 1, 2, and 3. Okay, you have 1, 2, and 3. Fine. So both of them are getting 2. Okay, both of them are getting 2, and we have this one. Okay, we have this one. So this one and this one can be done in only one ways, and this one can be done in 5 ways. So exactly 2 are getting 2. Exactly 2 dices are getting 2. That cases we are considering when we are getting exactly 2 dices are giving 2. So one is that both of these A and B are getting 2. Another is that this A and C are getting 2. These dices are getting 2, and this one is not getting 2, so this one can get any of the 5 outcomes. And what else is left? This one and this one are not getting 2, so only this one is getting 2. So okay, so you have 5 plus 5 plus 5, that is in total you have 15 cases, and 15 plus 25 is what? 90. Okay, and then you have one more left. Okay, one more left, so 90 plus 1, so that is 91. So that becomes 91. Okay, so this is how you can do these kind of questions. Okay. Fine. Now let us look at this question. All 6 letters of the name Sachin are arranged to form different words without repeating any letter in any one word. Okay. The words so formed are then arranged in a dictionary. What will be the position of the word Sachin in that sequence? Okay. So this question is asking that make all the permutations of the word Sachin. Okay. Make all the permutations of the word Sachin, but tell me that uh, what is the position of Sachin in the dictionary? Okay, what is the position of Sachin in the dictionary? So how we will do these kind of questions? Now look at this question. So basically it is saying we have to make all the arrangements of Sachin. Now all the arrangement of the word Sachin are possible in how many ways? This is a 6 letter word. So factorial 6 ways. Okay, so factorial 6 ways. And what is factorial 6? 6 into 5 into 4 into 3 into 2 into 1. Okay, so what is this basically? This is 24 into 5 is 120. Okay, this will be 4 5s are 20 to carry. This will be 120. And 120 into 6 is 720. So total number of words are 720. Okay, so this 751 is obviously not the answer. Okay, now let us see that what is the position of the word Sachin. So we start from here. Okay, so let us start from A. If we see A, okay, if we fix A as our first word because it will start from A obviously. So then how many words will be there which contains A as its first word? So that will be A is fixed and those will be factorial 4. And what is factorial 4? 24. Sorry, this will be factorial 5 because this is a 6 letter word. Okay, and A is fixed. Okay, this is a 6 letter word. Yes. So A is fixed. So how many words with A being the first letter will be present? 120. Okay, 120. Fine. Then what will come? C will come. Okay. Then all these words will take place, all the permutations of C. Okay. So you have 1, 2, 3, 4, 5 words left. Again 120 words. Then H will come, then again 120 words, then I will come, then again 120 words. How many words? 480 words have already been crossed. Okay, 480 words have already been crossed. So that means that, okay, similarly, we know P, Q, R, S, T, U, V, W. So N also comes before S. So we'll consider N as well. So 1, 2, 3. So factorial 5 here also. So you have 120. So total, how much you are getting? Total, you are getting 600 words. Now this is Sachin. So if you like see Cachin, this is in alphabetical order only because A will come, then C will come, then H will come, then I will come, then N will come. So Sachin will be the first word of the words that will start from H. So you will get how many words? 601 words. Okay. So so the position of Sachin will be 601. Okay. I hope you understand this thing. See what I am doing here. It is asking me all the 6 letters of the name Sachin are arranged to form different words without repeating any letter in one word. The words so formed are then arranged in a dictionary. What will be the position of the word Sachin in that sequence? So you have Sachin. Okay. You have Sachin. Fine. So you have 1, 2, 3, 4, 5. Okay. You have 1, 2, 3, 4, 5 words. Now this is Achin. Okay. Achin. So what is there? What will be the position of the word Sachin? So you have this S. Okay. You have this S. Okay. So you will start from the word A. First fix your A words because all the words that are starting from A will be there in the dictionary first. So all the words starting from A, how many total number of the words will be there? So in the first place, you are fixing your A. So how many places are left? You are left with 5 places. So this will come to be factorial 5, that is 120. Okay, this will come to be factorial 5, that is 120. Then C, how many words starting with C will be there? Factorial 5, that is 120. How many words starting with H will be there? Because we are seeing the sequence. So that will be also 120. How many words starting with I will be there? So that will be 120. And how many words starting will be N will be there? So that will be 120. Okay. So then you are left with this. So you are having Sachin. Okay. Sachin. So this is what? This is your, so 120 into 5 is what? 600. And the last word that is left is 601. Okay, so it is 601. Okay, so this is how you do these kind of question. Now let us move forward. Now 5 balls of different colors are to be placed in 3 different boxes. Okay, 5 balls of different colors are to be placed in 3 different boxes such that any box contain at least one ball. What is the maximum number of different ways in which this can be done? So 5 balls of different colors. Okay, so we have, um, let's say 5 colors are violet, indigo, blue, green, yellow. Okay, so these are 5 different colors are to be placed in 3 different boxes, and these are, let's say, these are uh, D, E, and F. These are 3 different boxes. Okay, 3 different boxes are there. Okay, 3 different boxes are there. What is the maximum number of different ways? Okay, such that any box contains at least one ball. Such that any box contains at least one ball. What is the maximum number of different ways this can be done? Okay. So any box has to contain at least one ball, okay? And 5 balls of different colors are to be placed in 3 different boxes. So this is the thing. So see, if we are start filling, we are having this D box, okay? All box are different, all colors are different. So earlier we are starting, we have one ball only. We are putting one ball, okay? So we'll make the arrangement. See, there are 5 balls and they have to be put in 3 boxes. So how many ways you can put? Either you can put one ball here, and 3 balls here. Okay. Or you can put one ball here, 3 ball here, or one ball here. Or you can put one ball here, sorry. Or you can put 3 ball here, one ball here, and one ball here. So this is the combination when we are putting 3 balls in one place and one ball in uh, uh, 2 places. Okay. Now, what is another combination? So we have this D, E, F boxes. Okay, we have this D, E, F boxes. Okay, so this can be done. Either we are putting 2 balls here. Okay, if we are putting 2 balls here, then let's say we are putting 2 balls here also, and we are putting one ball here. Okay, then three kind of combination. This also 1, 2, 2. Okay, and 1, 2. We have done this 1, 2, 2. Then we have this 2, 1, 2. Okay, this is the combination. Okay, so see, either we can do it this way or we can do it that way. We can't put 4 ball anywhere because then any other box will be empty. Okay, so we have this 6 cases only. We have this 6 cases only. Okay, we have this 6 cases only. Fine. Now we have what? See, if we have like 5 balls and we are putting one ball here, so this can be done in 5C one way. This can be this can be done in now 4C one way because one ball is put here, so only four ball is left. And this can be done in 3C three ways. Okay, this can be done in 3C three ways. So multiply this case. Now this can be done in 5C one way. This can be done in 4C three ways, and this can be done in 1C one way. This can be done in how many ways? 5C three ways. This can be done in how many ways? So 5C3, now there are how many balls left? Uh, uh, Only two balls left, so 2C one ways, and this can be done, only one option is left. Okay, only one option is left. Let us calculate for this. You have this 5C two ways. Okay, here how many balls are left? 3C two ways, and this can be done only in one way because only one ball is left. This can be done in 5C one way. This can be done in 4C two way, and this can be done in 2C2, or that is equal to 1 also. Okay, this can be done in 5C two ways. This can be done in how many ways? 5C2. So this can be done in 3C one way. Okay, 3C one way, and this can be done in 2C two way. Okay, so this is basically that you can do this in only in one way. Okay, we can do this only in one way. So you have this as 5C2, 3C1. Okay, and this is 2C2. Fine. Now this is D. The D is 5C1 way. So this is 5 only because 5C1 is what? Factorial 5 divided by factorial 1, okay, and factorial 4. So this will become 5 only. What is 4C1? 4 only. What is 3C3? What is 3C3? Factorial 3 divided by factorial 3, and 3 minus 3 factorial. So that is 1 only. Okay, so this case gives us 20 ways. Okay, this will give you how many ways? 5. What is 4C3? 4 into 3 into 2, and what is 3? This will be 3 into 2 into 1. So this will be 4 ways. Okay. This can be done in 4 ways. Okay. So 5 into 4, and this can be done only in one way. So we are again getting 20. Now do this again. You will get the same result. What is this? Is 5C3. 5 into 4 into 3 divided by 3 into 2 into 1. So what are you getting? 3 and 3 cancel, 2 and 2 cancel. You are getting 10 here. Okay, 10 here. Okay. And what you will get here? You will get 2 here because factorial 2 divided by 2 minus 1 ka factorial, and 1 ka factorial. So that is 2 only. So again 20, and that will be done by 20 way. So actually all these cases are same only. So you get 20 plus 20 plus 20, you get 60 ways of doing these things. I'm just telling that whenever you have this kind of arrangement, so what is the real thing that is happening here? Okay, then you have this 5C2. What is 5C2? We already calculated, I think, what is 5C2. If not, then it is easy only. 5 into 4 divided by 2 into 1. So what are you getting? 10 ways of doing this thing. What is 3C2? 3 into 2 divided by 2 into 1. So this is 3 only. Okay, this is 3 only. Fine. And this is 1 only. So you are getting 30 ways of doing this thing. Okay. Now, and now you have 5C1 here. 5 ways of doing this thing. You have 4C2. What is 4C2? 4 into 3 divided by 2 into 1. So this is what? 2. So this is 5, this is 6. Okay, this is 6. And what is 2C2? 1 only. So this is also 30. Okay, this is also 30. And what is this? 2, 1, 2. This will also come 30 only because 5 into 4 divided by 2 into 1. So this is 10. 3C1 is nothing but 3 factorial 3. Sorry, this will come to be 3 on 3. mm, Factorial divided by 3 minus 1 and 1 ka factorial. So this is will be 3 only. Okay, this will be 3 only. So this comes to be 10, this comes to be 3, and this comes to be 1 only. So you again have what? You again have 30. Okay, so 30 into 3, that is 90, plus you have 60. How many cases you are getting? 150. Okay, how many cases you are getting? 150. So this is the answer. See, this question could have been done very directly also. What you could have been done here is that don't take this 113, 131, or 311 arrangement. We could directly could have calculated this case, okay, and then multiply by 3. So that will be 3 into 20, and we could have directly taken this case. So we got 30, so directly multiplied by 3, so you'll get 90 plus 60, that is 150. So I hope you are clear with this thing. I hope everybody is clear with this thing. Okay. Fine. Uh, okay. So I hope this question was clear to you. We did it in very detail. What we did here was we first took balls of different colors. So I am taking balls of these colors and I took box D, E, F. Okay. I took boxes as D, E, F. Now I am putting these balls so I can, so when I am taking at least one, so when I am putting 1, 1, 3, so when I have these five balls, I can do this in 5C1 ways. When I have these four balls left, I can do this in 4C1 ways. And when I have these three balls left, I can do this in how many ways? 3C3 ways. That is equal to 1 only. So 5C1 into 4C1. So how many ways we are getting? 20 ways we are getting. Okay. And see, now this is the condition that only that will repeat. So 131 or 311. So just multiply 3 here, you get 60 here. Okay. Now you have another case DF. I am saying that at least one wala bola tha. So we put one here and rest two and two here. So we will get 5C1 here, we'll get 4C2 here, and then we'll get 2C2 here. So 5C1 is what? Nothing but 5. 4C2 is nothing but factorial 4. 4 into 3 divided by 2 into 1. So that is going to be 6. Okay, and this is 1 only. So you get 30. And there will be three cases like this, 212 or 122. So 30 into 3, that is 90. So you get 60 plus 90. And this becomes how much? This becomes 50, 150. So this is how we do these questions. Okay, this is how we do these questions. So let us move on to the next question. Now look at this question. Amit has five friends, three girls and two boys. Amit's wife also have five friends, three boys and two girls. In how many maximum number of different ways can they invite two boys and two girls such that two of them are Amit's friends and two of them are his wives? Okay. So what this is saying, Amit has five friends. Okay. Five friends means he's having three girls and two boys. Okay. Amit's wife also has five friends. Okay. Amit's wife also has five friends and they are having how much? Three boys and two girls. Okay. So this is Amit, this is Amit's wife. In how many maximum number of different ways can they invite two boys and two girls such that two of them are Amit's friends and two of them are his wife's friends? Okay. Two of them are Amit's friend and two of them are his wife friends. Okay. Fine. So now let us see two boys and two girls we have to invite. Okay. So see what we can do. We have two boys to invite and two girls to invite. Okay. So what we can do, either we can invite one boy from Amit and one boy from uh, his wife. Okay. And one girl from Amit and one girl from his wife's friends. Okay. Either we do this condition or we do that both the boys we invite from Amit, so then both the girls will invite from Amit's wife only. Okay, both the girls will invite from Amit's wife only. Okay, next condition is what? Both the boys we invite from wife, and then both the girls will have to be invite from Amit's friend only. Okay, so either we invite one boy and one girl from Amit, one boy from Amit and one boy from Amit's wife's friends, or one girl from Amit's and one girl from Amit's wife's friends. Okay, or we invite two boys from Amit's friend and two girls from Amit's wife's friends, or we invite two boys from Amit's wife friend and two girls from Amit's friends. Okay, so now see, this is the condition we are getting. Okay, let us write this nicely. So the first condition is that one boy from Amit and one boy from Amit's wife and one girl from Amit and one girl from Amit's wife. So let us see in how many ways we can do this. So one boy from Amit. Amit has five friends, three girls and two boys. So one boy from Amit you can choose in 2C1 ways. Amit's wife has five friends, three boys. So Amit's wife you can choose in 3C1 ways. Okay. Then let us consider girls condition. So one girl from Amit. So there are three girls, so you can invite in 3C1 way. And there are two girls here, so you can invite them in 2C1 ways. So basically 2 into 3 into 3 into 2. So what is this? 9 into 4. So that is 36. Okay. 9 into 4, that is 36. Now let us look at the next condition. So now what I am doing, second condition, I am inviting both the boys from Amit and both the girls I am going to invite from Amit's wife. Okay. So when I am inviting both the boys from Amit, so that can be done only in one way. Okay, because two boys are there, I can invite them in two only one way. Okay, then I am left with both the girls from Amit's wife friend. So this can be done in only in one way. So this is what this is only one way of doing this thing, that both the boys Amit's friend come and both the girls from wife are coming. Okay, so this is one condition. Second condition. The third condition is that both the boys are coming from Amit's wife friends. So that can be done in 3C2 ways. Okay, and both the girls are coming from Amit's friends. Okay, so this can also be done in 3C2 ways. Okay, what is 3C2? Factorial 3 into 2. So 3 into 2 divided by 2 into 1. So this is done in three ways, and this is also done in three ways. So 3 into 3 is 9. You have one more condition, you have 10, and you have this 36. So 36 plus 10 is how much? 46. Okay, 46. So I hope now you are clear with this thing, how you are making these combinations. Okay, I hope you are clear with this thing, that how you are making these combinations. Okay, so this is how we do these questions. Now let us move forward. I hope everybody understand this well. See, what we did here is, let us like look at this question once more. We took three cases. Okay, we took three cases because they are saying in how many maximum number of ways we have to invite two boys and two girls, such that two of them are Amit's friends and two of them are his wife. So actually we have four positions of two boys and two girls, but we have to choose from Amit Amit's friend two people, and from Amit's wife friend two people. Okay, so we make cases here. First case is what? We are getting one boy and one girl from Amit, and one boy and one girl from his wife. Second case, what we did here, we are taking two boys from Amit, and we are taking two girls from Amit's wife. And then what? The next case is two girls from Amit and two boys from Amit's wife. Okay, so these are the case. Other than this, there is no other case. Okay, so one boy from Amit, so that means there are two boys, that can be done in 2C1 ways, multiplied by one girl from Amit's wife. So two girls only, 2C1 ways, and one boy from Amit's wife. So that can be done in 3C1 ways, and one girl from Amit's Amit's wife. So that can be done in uh, 2C1 ways. Oh, sorry, this girl can be done in 3C1 ways. Okay, so you get 2 into 3 into 3 into 2. So that is 9 into 4. So that is 36. Okay, that is 36. Then two boys from Amit. There are only two boys. Only one way you can do this. There are only two girls for Amit's wife. So only one way you can do this. So you get 2 here. Okay, you get 2 here. So this becomes 38. But wait, there is one more condition left. Two girls from Amit. How many ways you can choose? 3C2. So that becomes what? 3 into 2 divided by 2 into 1. So this is 3 only. And Amit's wife also having three boys friends. So 3C2. So that can be done in 3 into 2 divided by 2 into 1. So this can be done in three ways. So 3 into 3 is how much? 9. And 9 plus one condition. Okay, one condition here. Oh, sorry, this is one condition only, not two condition. So you have this 10 plus 36, so that is 46. So this is it. Okay, this is it. So this is how you do these kind of questions. Now let's move forward. Now look at this question. In the given figure, what is the maximum number of different ways in which 8 identical balls can be placed in small triangles 1, 2, 3, 4, such that each triangle contains at least one ball? Okay, so we have four different. See, this figure is nothing but we have four different places to be filled. Okay, whatever they give you, you actually have what? You have four different places to be filled. Okay, and it is just saying that each triangle should have at least one ball. Okay, so if I take this triangle or I take this four different places, okay, so that is the same thing, and the balls are identical, so arrangement will not matter. Okay, balls are identical, so arrangement will not matter. Okay, so that means I don't have to I just have to choose the number of balls that can be placed. Okay. I just have to choose the number of balls that can be placed. Okay. So what is the possible number of combinations? So if let us say it is asking at least one ball in each triangle. Na? So one, and one. So if you are putting one and one ball here, and you are putting, how much balls are left? You are putting 5 balls here. Okay, you are putting 5 balls here. So this is one way of doing thing. Okay, now see, this can be done in how many ways? This can be done in, like, either you are putting one and one ball here. Okay, now these are all different places, so that arrangement will matter which we are putting balls. Okay, so let's say I am putting this 1 1 5 1. Okay, and I am putting this 1 5 1 1, or I am putting this 5 1 1 1. Okay, so this will matter. Okay, this will matter. Okay, so this can be done in 4 ways. This can be done in how many ways? 4 ways. Now the next arrangement, let us see. Okay, so I am putting one ball here, but then I am putting, let's say, two ball here and two ball here. So this is how much? 3 plus 2, 7. Okay, sorry, 3 plus 2, 5, 5. And then how many balls are left? 3 balls are left. So these kind of arrangement we are asking. Okay, because these are identical balls. So uh, identical balls, so we don't have to worry about like arrangement of the balls. Okay, fine. So let us like look at how many ways. Okay. So now see what we can do here when we are putting this 1, 1 and 5. Okay. 1, 1 and 5. So these are like four different items put in four places. So this can be done in factorial 4 ways, but these three is identical. So just divide by how much? Just divide by 3 factorial. So that will become factorial 4 by factorial 3 ways. Now let us say we are having two ones. Okay. One arrangement we are having that we are filling two places by one. Okay. Then the next two places will fill by, let's say, one place we are filling by, we have 8 balls, so only two are used. Okay, so one we are filling by, let's say, 2, and another we are filling by, let's say, 4. So now we have four different places to be filled, so that can be done in factorial phase 4 ways, but we have only two identical things. So factorial 2 ways. Okay, we are having only two identical things, so we can do this in factorial 2 ways. Okay, fine. Now, what is another arrangement? That let us put uh, one ball here, one ball here. Okay, and uh, the next we are having this 3 and 3 ball. Okay, the next we are having this 3 and 3 ball. So now this is also it. Now factorial 4 divided by factorial 2 into factorial 2 ways. Okay, factorial 4 divided by factorial 2 into factorial 2 ways. Now we are having only one place where we are putting one ball. So this can be done in how many ways? If you are putting one place here, so now put 3 in one place and put 2 and 2 in another place. So you're having how much? This is 7 and this is 8. So now this can be done in factorial 4 divided by factorial 2 ways, because two things are distinct. Okay. Now what is left? Now you're done with one ball everywhere. Okay, so now let us put two ball here. Okay, let us put two ball here. So you will put two ball here, so put two ball here, to put two ball here, two ball here as well. So this can be done in only one way. Okay, this can be done in only one way. So total how many ways you are having? This will become 4. This will be 4 into, actually 4 into 3 divided by 4 into 3 only. Okay, so this will be 12. Okay, this will be 12 divided by 2, that is 6 only, and this will be 12 again, and this will be 1 only. So how much is there? 4 plus 12 plus 6 plus 12 plus 1. So this is 24, this is 10, so this becomes 34, and you get 35 ways. Okay, 35 ways of doing this thing. Okay, so see, in the beginning, I was telling you what kind of arrangement it is. Okay, but see, instead of going for each and every case, what I did was I just did it like arrangement. Okay, so this 8 identical balls. Okay, 8 identical balls, we have to fill it in 4 places. We just forget this 1 2 and 3 4. Okay, just we have to fill it in 4 places. Let's say these places are A, B, C, and D. Now these 8 identical balls are there, so we don't have to choose from these balls because these are identical. So anyone we are choosing, that is the same case, so that we don't have to consider. What we have to consider, what we are filling. Okay, so if we are choosing to put one here, if we are choosing to put one here, we are choosing to put one here, and we are choosing to put, let's say, 5 here, because 8 balls, so 1 1 and 5. Okay, so we have 1 1 and 5 here. Okay, so this can be done in how many ways? Factorial 4 divided by factorial 3 ways. Okay, because this will be like 1 5 1 1, 5 1 1 1, and one arrangement will be 1151. Okay, so factorial 4 by factorial 3 ways. Okay, and then we have 1, 2, 3, 4. Okay, so this can be done. These are 8 identical balls, and how many ways this can be done? So you have 1 and 1. Okay, you have 1 and 1, and then you have 3 and 2. Okay, you have 1 and 1, and then you have 3 and 2. Is this possible? Because 3 plus 2 is 5, 5 plus 2 is 7. Not possible. So you have 1 and 1 and 3 and 3 you will have to take. If you are we are one case we are considering at three places we have one balls. Another case we are considering at two places we have one ball. Okay, so when at two places we are having one ball, so 1 and 3 will only be the case. So this can be done in how many ways? Factorial 4 by factorial 2 way, divided by factorial 2 ways. Okay, factorial 4 by factorial 2 divided by factorial 2 ways, because these two are identical, these two are identical as well. Okay, so this is the case. Another case is there only one ball we are having. Okay, one ball we are having. So one where we put two. Okay, if only one we are having at least one case. So one place we can put two. Another place let us put two only. So two plus two four. Four plus one five. So another place we can put three here. So this can be done in how many ways? Factorial 4 divided by factorial 2 ways, and the next case we are having that no one is 1, so everybody will have to be 2 if no one is 1. So this can be done in only one way. Okay, so now you have like factorial 4 divided by factorial 3. So this is coming to be 4 ways. When you are doing this, factorial 4 divided by this, so this is coming to be 4 into 3 and 2 into 1. So this is coming to be 6 ways. Okay, this is coming to be 6 ways. Okay. 4 into 3 divided by 2 into 1. So this is coming to be 6 ways. And what is this coming to be? 4 into 3. Uh, Sorry, this is coming to be 12 ways. Okay. And what is this coming to be? 4 into 3 divided by 2 into 2 into 1. So this is coming to be 6 ways. Okay. This is coming to be 6 ways. I think there is one more case that we already considered, but then we are leaving it here. Okay. Then we are leaving it here. So which one is that case? Um, So if we are considering two ones, if we are considering two ones, so then we can consider, if we consider two at one place, so this is how much? 1 plus 2, that is 4 only. So we can consider 4 at one place. So only this case we'll have. So that will be done by factorial 4 plus factorial 2 ways. So 12 more. So now you can add 12 plus 12 is 24. And then you have 1 6. So that becomes 30. Then you have this 4. That becomes 34, and then you have this one also, so this becomes 35. So we can do in this many ways. Okay, we can do in this many ways. So I hope everybody is clear with this. Okay, so now let's move on to the next question. Okay, let's move on to the next question. Look at this question. Six equidistant vertical lines are drawn on a board. Six equidistant horizontal lines are also drawn on the board, cutting six vertical lines. And the distance between any two consecutive horizontal lines is equals to the distance between any two vertical lines. What is the maximum number of square formed? Okay, what is the maximum number of square formed? So basically what they are saying, you are having six vertical lines. Okay, one, two, we are just visualizing this. We will obviously calculate three, four. Okay, one, two, three, four, five, and this is six. Okay, and then we have six equidistant vertical lines. Okay, so one, two, three, four, five, and this is 6. Okay, and this is 6. We have 6 equidistant vertical line as well. You have this 6 equidistant vertical line. Now obviously you can calculate 1 2 3 4 5. Okay, 5 square in one row. How many rows are there? 1 2 3 4 5. So 5 into 5. Okay, this is the, like, this is the smallest square. Okay, this is the smallest square possible. So these are 25 obviously. These are obviously 25. Now let us calculate these squares. These are also squares. Okay. So how many squares will be there? You have uh, you have this square as one. you have this square as 1, you have this square as 1, okay, and you have this square as 1. So for two rows, you are having how many squares? For these two rows, how many squares you have? One square is this one, okay, another square is this one, sorry, another square is this one, okay, another square is this one, okay, and another square is this one, okay, this one. So for these two rows you are getting 4 square. For these two rows also you will get 4 square. For these two rows also you will get 4 square, and for these two rows also you will get 4 squares, okay. For these two rows also you will get 4 squares, fine. So how many squares are there? 4 plus 4 plus 4, 4 into 4, 16. So put 16 here. Okay. Put 16 here. Okay. So we have this 25 plus 16 squares. So that becomes how much? 5 plus 6 is 11. 1 here. So you have 2 plus 2, 4. 4. 41 square here. Okay. 41 square here. Now let us find some more square. Okay. Let us find some more square. Okay. So, yeah, let us find some more square. So, see, if we consider like equal number of boxes, we have to consider now. So, when we are considering these boxes, we are considering 1, 2, 3, 4 boxes. So, let's now consider more boxes. In this case, we considered 4 boxes. Now, let us consider 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes. Okay. So, this is also a square. This is also a square. So this is also a square. So this is also square. So for 3 rows, for 2 rows we got 4 squares. So for 3 rows also we are getting 3 squares. Okay. For for these 3 rows we get 3 square. For these 3 rows we will get 3 square. And for these 3 rows as well we get 3 square. Okay, we'll get 3 square. Okay. Fine. So how many squares we are getting? So we got like earlier we get 25 plus 16, and now we are getting 9 squares. Okay. Now we are getting 9 squares because we made 1, 2, 3, 4, 4, 5, 6, and this is 7, 8, 9 square. Okay. 7, 8, 9 square. So for 3 rows we considered. Okay. For 3 rows we considered. Now let us consider for 4. Okay. So I'll consider 1, 2, 3, 4. 1 2 3 4, 1 2 3 4, and 1 2 3 4. This is also a square. Okay, so one square is this one. Okay, then consider, we are considering, no, so 1 2 3 4, one square is this, and one square is, let's say, this one also. Okay, one square is this one also. So how many squares I am getting? For 4 rows, I am getting 2 squares. For 4 rows, I am getting 2 squares. Okay. So for these 4 rows, I am getting 2 square, and for these 4 rows also, I'll getting 2 square. Okay. So how many square I'm getting? I'm getting 4 more square. Okay. I'm getting 4 more square. Okay. Now total I have from 6 lines. Total I have how many rows? 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Okay. Now, for all the five, if I am considering all the 5 rows, okay, all the 5 rows. So 1, 2, I'll consider now five boxes I'll consider. So this whole is also a 1 square. So one more. Okay, so one more. So how many total number of square did I get? I get 25 plus 16 plus 9. Okay, plus 5. Okay, so this 5 plus 5 is 10. The 6 plus 5, 9 is 15. Okay, so I have 25 here. 2 carry. Okay, 2 carry, and 2 plus 2 is 4, and 1 is 5. So you get total number of squares are 55 here. Okay, total number of squares are 55 here. So I hope you are clear with this, how I am counting these squares. Okay, I hope you are clear with this, how I am counting this square. So basically, you have to like you have to like make these things. Okay, now see, there is one more thing in there is one more way in which we can do. So you are giving 6 equidistant vertical lines and 6 equidistant horizontal lines. Okay, so the number of like boxes you will make is how much? 5 boxes. Okay, you will make these 5 small boxes. So whenever you are given this thing, and you can make these 5 boxes from these 6 horizontal and vertical line, 5 square boxes. So the number of squares can also be given by 1 square plus 2 square plus 3 square dot 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 n square, where n is what? The number of these boxes you are making. So that is 1 square plus 2 square plus 3 square dot 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 5. Okay, 5 square. So total, if you calculate this, it will become 55, because 1 plus 2, that will become 4, this will become 9, this will become 4, will become 16 and 25. This is only the thing we get now, because when we were considering all these five boxes, है ना, all these five boxes when we were considering, then we get how many? We got like only one. Then when we consider four boxes, how many we got? When we consider this one, two, three, four, okay. So I got one square this one square this one square this one square this one. So I got four square. When we are considering three, how many we got? Nine. When I consider only two rows, how many we got? 16. When we are considering these five boxes all, so how many we got? 25. Okay, so that is given by 1 square plus 2 square plus dot dot n square, where n is what? The number of smallest unit of square you get. Okay, so that is given by 55. So I hope everybody is clear with this thing. Okay. Now let us understand this. Groups containing each three boys are to be formed out of five boys. Okay, A, B, C, D, E, such that no groups contains both C and D together. What is the maximum number of such different groups? Okay. Now see, it is saying that these A, B, C, D, and E are five boys, and we have to find groups. We have to make groups of them. How? Groups of what number? Groups of three boys. Okay. Now this is saying that you have to find the number of groups in which such that no and groups contain C and D together. Okay, such that no groups contain C and D together. So what we'll do, we'll find the total number of groups. Okay, we'll find the total number of groups and we'll subtract them by the number of groups. We'll subtract them by the number of groups that contain C and D together. Okay, that contain C and D together. So in how many ways we can do this? You have this A, B, C, D and E. Okay, now we have these five boys and 1, 2, 3, 4, 5. Okay, so these, how many total number of groups? 5C3. Okay, now let us consider we are having the C and D together in all our groups. Okay, so that means two places are already filled. How many boys are left? Only three boys are left. So now one place has to be filled. This can be done in only 3C1 ways. So total 5C3 minus 3C1. So this will be coming to be what? 5 into 3, 5 into 4 into 3 divided by 3 into 2 into 1. And this can be done in how many ways? Only 3. 3C1 is 3 only. Okay, or you can do 3 divided by 1. Okay, so this is 3 and this will be 10. So 10 minus 3 is what? 7. So the total number of groups are coming to be 7. Very simple. Okay, total number of groups are coming to be 7. Now let us look at the next question. See, in how many different ways can three identical balls be placed in 12 square such that each ball to be placed in the exact center of the square and only one ball is to be placed in one square shown in the figure given above, such that they do not lie along the same straight line. Okay, such that they do not lie along the same straight line. So you are giving three identical balls. Okay, now it is saying each ball to be placed in the exact center of the square. So that means here, and only one ball is to be placed in one square such that they do not lie along the same straight line. Okay, they do not lie along the same straight line. So these are 12 places. Okay, so, like if you are placing these three balls now, so let us consider in what ways we can get straight lines. Okay, so for total number of cases is 12C3. Okay, because you have to choose either of these three places, and total number of ways you can do is 12 squares are there, so obviously 12C3. Now let us see the condition of the straight line. Okay, so if we put like here 1, 2, 3, this will be a straight line. Okay, so these are the four conditions will minus. Okay, these are the four conditions will minus. Okay, what are the other else condition that we can minus? You can minus these conditions 1, 2, 3. Okay, this is the condition you can minus. So how many conditions are there? 3 minus 3. Then you can minus this as well, 1, 2 and 3, minus this as well, minus 3. Okay, minus 3. Okay, now these are all the conditions we have eliminated. Okay, because these are three balls. Okay, now let's start with diagonals. So one diagonal is this one. Okay, one diagonal is this one diagonal is this one. Okay, so basically we have two diagonals here. So that means minus two cases. Okay, minus two cases. Okay, and what are the other ways we are having? We have one diagonal this one, and we have one diagonal this one. Okay, we have one diagonal this one, and we have one diagonal this one. So this will also be a straight line. Okay, this will also be a straight line. So minus two more cases. Now I think we have sufficiently considered the cases. Okay, we have sufficiently considered the cases. So if we are placing like here, here, and here, so these are four conditions where we will get a straight line. These are four conditions, this 1 2 and 3, this 1 2 and 3, or we can place here 1 2 and 3, 1 2 and 3. This will be straight line, or this diagonal and this diagonal, or this diagonal and this diagonal. Okay, so these are the number of cases you have to eliminate. Okay, so the total number of cases we are getting here that is to be eliminated here are, this is 2 and 2, that is 4, 4 plus 6 is 10, and this is 14. Okay, 14. Fine. And now what about this 12? Let us see. 12 into 11 into 10, and this will be 3 into 2 into 1. Okay. So this will become 2 only. Okay. How much cases are left? We are left with 220 cases. Okay. 110, and we are left with 220 cases. Minus 14 from here. Okay. Minus 14 from here. We are getting 14 only. Okay. Minus 14 from here. Okay. I think we calculated it correctly only. One, two, three, one, two, three. Fine. One, two, three, one, two conditions here we get, two conditions here we get, two conditions here we get this condition, we get this condition, we get this condition, we get this condition, we get this condition. Rest and we don't get any more conditions. Okay. So we have this as, this will come to be 6, this will come to be 0, this will come to be 206, but 204 is the option. Have we left anything? This will be 6, 10, and 14. Okay, see there are two conditions that are being left here. Okay, see what are the conditions that are left here are, see, if we are posing, if we are doing one ball here, and one ball here, and we are putting one ball here, and one ball here, and one ball here, and we are putting one ball here and one ball here. These are the three conditions we have to eliminate. Okay, and then one more condition will be what? We are putting like one ball here, one ball here, and one ball here. Okay, so these are also the three conditions that we have to eliminate. Okay. Um, Okay, these are the three conditions we have to eliminate. Okay, so we are like, we are putting a gap here, but then still, okay. So these are the conditions we need to eliminate. So one, what is the condition? This condition. Okay, we are putting one ball here, one ball here, and one ball here, and then one ball here and one ball here. Okay, so these are the conditions we need to like. Eliminate. Okay, so how many conditions we are getting now? See, now you are like getting six more here, so you have to just subtract 20 from here. So 220 minus 20, that will come to be 200. Okay, so luckily, see, I forgot to count some, but see what happened here is my answer came wrong, but that answer was not in the option, so I could like like I could recheck it. Okay, so obviously you can do this. See now what is there. We have this 1, 2, and 3, 1, 2, and 3, 1, 2, and 3. Okay, and then we have this as 1, 2, 3, 4. Okay, 1, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so this way we can obviously do it. See, what are the number of arrangement possible here are, see, 1, 2, 3, okay, 1 2 3. Okay, because three places will make a straight line. Okay, so we get how much? 3 plus 3, that is 6. Okay, four conditions here we are getting straight line, so we got this. Okay, four conditions here we are getting straight line, two conditions here we are getting straight line diagonally, two more conditions here we are getting straight line diagonally, and what else condition we are getting? We are getting this 1 2 3. So like one ball we are putting here, one ball 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 here. So these are the three conditions in which they are in straight line. And also if we are putting here and we are not putting here. Okay, so these are also the conditions of straight line. So total conditions how much? 10 plus 4 14, 14 plus 6 20, and total number of ways in which we can choose from these places is 12C3 minus 20. So this will be 220 because 12 into 11 into 10 divided by 3 into 2 into 1. So this 6 and 2, this becomes 220 minus 20. So this becomes 200. Okay, so this is how we can do these kind of question. Let's move on to the next question. This question, how many numbers are there in all from 6000 to 6999 having at least one of their digits repeated? Okay, see what we can do here. We can do like this, that total number of cases, okay, minus in which no digit is repeated. Okay, in which no digit is repeated. So if we are doing like this, that total number of cases we are able to calculate between 6000, total number of numbers between 6000 to 6999. Okay, and when no digit is repeated. Okay, when no digit is repeated. So I already told you the total number of numbers between this and this number including both are given by 6999 minus 6000 plus 1. So this is how much? 9999 plus 1, that is we are having total 1000 numbers. Okay, and then we have to calculate when no digit is repeated. Okay, so 6 will obviously always be fixed. Okay, then we have these 3 digit left. Okay, so this can be filled in how many ways? 9 ways. Okay, because 6 we can't fill here. Then this can be, we fill in 8 ways, and this can be done in 7 ways. So how many cases we are having? 72 into 7. So this will be what? 7 2s are 14, 7 7s are 14, and 50 minus 504. So 1000 minus 504, how much you are getting? Obviously 496 you are getting. Okay, obviously 496 you are getting. So this can be done in 496 ways. Okay, this can be done in 496 ways. So I hope you are clear with. So let us do some more questions here. Okay, let us do some more questions here. Each of the two women and three men is to occupy one chair out of eight chairs. Okay, each of which is numbered 1 to 8. First, the women are to occupy any two chairs from those numbered 1 to 4, and then the three men would occupy any three chairs out of the remaining six chairs. What is the maximum number of different ways which can be done? This can be done. Okay, so you basically have three chairs, 1 2 3 4 5 6 7 8 8, sorry, you basically have 8 chair, and these are numbered 1 2 3 4 5 6 7 8. Now it is saying each of two women and three men, you have total five people, two women you have and three men you have. Okay, 1 to 8, first women are to occupy any two chair between 1 to 4. Okay, so there are four places. Okay, there are four places, and there are two women. Okay, so here see what permutation will matter. So you can do this in 4p two ways. Okay, you can do this in 4p two ways. Fine. Now it is asking three men, this four women. So four women can select. Sorry, we are having this four chair, 1 2 3 4 5 6 7 8. Okay, so four women, we are having two women. Two women can select like how many places? 4 seat 2. But then arrangement will also matter. So factorial two ways. Okay, factorial two ways. Now see, now six places are left. Now six places are left. So they can choose in, these men can choose three chairs out of these six chairs in 63 ways. And how many chairs? And then arrangement is also mattering. So factorial three ways. Okay. So factorial three ways. Now this is what? 4 into 3 divided by 4 into 3. Okay, divided by 2 into 1. So this can be done in 6 ways. But then you have this 2. So you have 12 ways. This is what? 6 into 4, 5 into 4 divided by 3 into 2 into 1. So this is 20, and factorial 3 is what? Factorial 3 is I think 6. Okay, so how many ways? So you have this 120 into 12. Okay, this came to be 12. 120 into 12. Now what is 120 into 12? Obviously 1440. Okay, 1440. So this can be done in 1440 ways. So earlier what I did is I just made you visualize the situation. But when we are doing permutation, na, so then it is a little bit difficult. Okay, or you can write permutation as well. See what will happen here. You have this 1, 2, 3, 4, 5, 6, 7, 8 chairs. Okay, so when you are writing, like let's say you are writing about permutation, so out of these 4 chair, women will choose any chair in 4p2 ways. Okay, in 4p2 ways. Now how many seats are left? 6 seats are left. So now men can choose in 6p3 ways. Now what is 4p2? Factorial 4 divided by factorial 4 minus 2. Okay, factorial 4 divided by factorial 4 minus 2. So that is what factorial 4 divided by factorial 2. So that is 12. Okay, multiplied by factorial 6 divided by factorial 6 minus 3. 6 minus 3 factorial. So this is what? 6 into 5 into 4 into 3 into 2 into 1 divided by 3 into 2 into 1, because this is this much only. So this comes to be 4 5s are 20, 20 plus 6 is 120 into 12. So this is 1440. Okay, this is 1440. So this is how we do these questions. Okay, this is how we do these questions. So I hope this is clear with you. Okay. See, in this questions, what is the basics? Let us read this question. Each of the 2 women and 3 men is to occupy 1 chair out of 8 chair, each of which is numbered 1 to 8. First, the women are to occupy any 2 chair, those numbered from 1 to 4, and then the 3 men should occupy any 3 chairs out of the remaining 6 chairs. So, what is the maximum number of different ways this can be done? So, 1, 2, 3, 4, 5, 6, 7, 8 places we are having. Okay, so women will like have to fill from these 1 2 3 4 only, and then the 6 chairs are left, so men can choose from any those chairs. Okay, so this is the right solution of the question. Okay, so we'll see the solution further. Now look at this question. You have a box contains set of 5 balls, while there are 3 balls in each set. Each set of balls has one ball whose color is different from every other ball in that set and also from every other ball in any other set. What is the least number of balls that must be removed from the box in order to claim with certainty that a pair of balls of same color has been removed? Okay. See what is here. A box contains set of 5 balls. Okay. A box contains 5 set of balls while there are 3 balls in each set. Okay. So, what it is saying, a box contains set of 5 balls. Okay, set of 5 balls. We have 5 ball set, while there are 3 balls in each set. Okay, so we have 5 sets. Okay, we have 5 sets, and these are having 3 balls each. Each set is having 3 balls. Okay, each set is having 3 balls. Each set of balls has one ball whose color is different from every other ball in that set and also from every other ball in any other set. So, what is the least number of balls that must be removed from the box in order to claim with certainty that a pair of balls of the same color has been removed? Okay, that a pair of ball uh, that a pair of ball of the same color has been removed. See, let us consider this ball is like colored. Okay, this ball is with the color that is different from these two and from each of these two. Similarly, this one also, this one also, this one also, and this one also. So we know for certainty that there are 5 balls who do not match with any other color. We know with certainty we have 5 balls who do not match with any other color. Okay. And how many balls are left? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 balls are left. Okay. 10 balls are left. Okay. Now you know that remove 9 balls from this. Okay. Remove 9 balls from this. Let one ball be left because that ball color will be different. Okay, that ball color will be different. Don't remove all the 10 balls. Remove only one ball. Remove only 9 balls, because you know one, these are all from different color. Now if this one matches this one, or this one matches with any other also, but then also if we remove every other 9, one is left, that is like having the different color. Okay, so total 6 balls we will have here. Okay, 1 2 3 4 5 will total 6 balls will have here, and 10 balls we are having here. Okay, uh, so we'll remove 9 balls. Okay, so we'll remove 9 balls from here. Okay, we'll remove 9 balls from here. So actually the question is saying that you have like a box is there, you have 5 sets of balls, and each set contains 3 balls. Each set contains 3 balls. Okay, each set contains 3 balls. Now they are saying that we have like in each set we have one ball which is different from these two and from any other of these balls. Okay, so one, these 5 balls will keep. Okay, we are considering that these are the 5 balls who are of different color. And how many balls are left? 10. So we'll not remove all these 10, we'll remove these 9. So even if this matches this one or this one, so they have already been removed. So remove 9 balls. Okay, so this is your answer. So I hope everybody is clear with this thing. Now we end with this class. Okay.